Catching ship is SpaceX's next great milestone after the success of Flight 10. The question now is when will it happen? Musk has offered new details, giving us a clearer view of the path ahead and the preparations needed to make this bold plan a reality. What exactly did he reveal, and how is SpaceX preparing for this daring step? Let's find out on today's episode of Great SpaceX. It can be said, without exaggeration, that the journey of both Starship stages in Flight 10 was a remarkable success, especially when compared to the outcomes of previous flights. For the first time, both stages achieved controlled landings, and they did so while new and challenging tests were being conducted. This performance not only validated SpaceX's approach to iterative development, but also set the stage for what is perhaps the most ambitious goal yet: catching both stages with the Mechazilla Arms to achieve true full reusability. This long-awaited milestone, recently highlighted in a vivid 3D animation released by SpaceX, has captured the attention and imagination of enthusiasts worldwide. The question that follows is straightforward. When exactly will SpaceX attempt this daring catch? Prior to Flight 10, there were already two possible scenarios being discussed. The first was that SpaceX might attempt a catch as early as Flight 11, which is planned to be the final V2 flight and could serve as a testbed before transitioning to V3. The second possibility was that the company would wait until Flight 13, the second V3 flight, giving them additional time to refine the technology and strategy. Musk himself has now provided the answer. On X, he stated, "Starship catch is probably Flight 13 to 15, depending on how well V3 flights go." This revelation confirms one of those earlier predictions and shows that SpaceX is choosing a more cautious yet strategic approach. By delaying the catch attempt until the second V3 flight at the earliest, they are ensuring that the hardware and systems have been tested thoroughly enough to maximize the chances of success. Musk's statement also makes it clear that this could slip to Flight 14 or even 15, depending on the performance of the early V3 vehicles. Timing is another crucial factor. Musk explained that SpaceX is currently aiming for a launch cadence of roughly one flight every 2 months. If that schedule holds, Flight 11 would likely occur in October, 12 in December, and then 13, 14, and 15 could fall around February, April, and June of next year, respectively. However, there is reason to believe the pace could accelerate. The hardware for Flight 11 is already showing promising progress, and with successful results, SpaceX could very well move faster, bringing the catch attempt forward by several weeks or even months. Choosing to avoid a catch during Flight 11 and Flight 12 makes sense from both a technical and a safety perspective. Flight 11 would serve as the last V2 test, focused on perfecting existing systems without introducing major changes. Flight 12, the debut of the V3 design, will already involve numerous upgrades and innovations. Attempting to catch during such a transitional flight would add unnecessary risk. By waiting until 13 or later, SpaceX will have the benefit of lessons learned and the opportunity to confirm reliability before attempting such a critical step. This cautious schedule also aligns neatly with SpaceX's broader timeline for Starship development. If the first successful catch occurs in early 2026, the middle of that year could then mark the beginning of work on orbital refilling demonstrations, a cornerstone capability for interplanetary missions. By the end of 2026, SpaceX aims to be ready for both the HLS uncrewed lunar landing demonstration and the first uncrewed mission to Mars. Catching both stages successfully is not just a symbolic milestone, but a vital enabler for this sequence of ambitious missions. In the meantime, the upcoming two flights will still play a crucial role in preparing for this milestone. Both stages will once again attempt controlled landings into the ocean. For Super Heavy, this will mean continuing to refine maneuvers such as the active flip, experimenting with steeper landing angles, and testing landings at reduced engine power to create redundancy for future missions. For Ship, these flights will involve extensive testing of the heat shield, including experiments with different tile configurations, metallic tiles, and advanced cooling systems. It's also possible that these flights will see Starship reach full orbit, potentially carrying larger payloads or even real payloads to space as part of the testing process. Each of these tests will build confidence in the navigation, deceleration, and stabilization systems that are critical for returning Ship to the launch site and into the waiting arms of Mechazilla. The successful demonstration of these systems will be the foundation for attempting the catch, which which represents one of the boldest leaps in the history of rocketry. So the path forward is clear. Flight 11 and 12 will set the stage by validating upgrades and proving reliability. From Flight 13 onward, the true test of catching Starship begins. Whether it happens on Flight 13, 14, or 15, this attempt will be a defining moment for SpaceX, marking the transition from reusability to full rapid reusability. Do you think the timeline set by Musk and SpaceX is realistic? Please share your thoughts in the comments by responding with yes or no, along with your opinion. Then, don't forget to like the video and subscribe to our channel so that you can continue following SpaceX's incredible journey toward making the impossible possible. Of course, SpaceX must prepare carefully if it wants to keep pace with the ambitious schedule that lies ahead. Much of this preparation will involve both the vehicles themselves and the ground infrastructure that supports them. Each element must be tested, refined, and verified in order to make catching both Starship and Super Heavy with the Mechazilla Arms not only possible, but reliable. Starting with the vehicles, the ship will need to receive its catching point system. This is the hardware that will connect with the Mechazilla Arms during the landing attempt. The current plan is to install and test the older design during Flight 11, followed by the upgraded design on Flight 12. These early flights will be crucial to prove that the catching points can survive the stresses of launch, re-entry, and splashdown. Only once they are validated will SpaceX commit to using them in an actual catch attempt. A similar approach will be taken with Super Heavy. The V3 upgrade for the booster is expected to include catching points integrated directly with the grid fins, marking a clear step forward in the design. The return journey of both stages will depend heavily on their engines. For Flight 11, SpaceX will still use the existing Raptor 2 engines, but the real focus will be on Flight 12, which will debut the long-awaited Raptor 3. This new version is designed to be more powerful, more reliable, and less complex than its predecessor. Before it flies, however, it'll need to prove itself during a series of static fire tests. These tests will not only confirm its thrust output, but also demonstrate its precision and reliability, both of which are essential for accurate navigation and controlled landings. In addition to the engines, the navigation and landing systems must perform flawlessly. For Super Heavy, this includes the grid fins, which provides steering during descent, while for the ship, the flaps play the same critical role. These aerodynamic surfaces will need to work seamlessly with the Mechazilla Arms to guide the vehicles into position for a safe catch. While ship's design has not changed much in this area compared to V2, the aft flaps remain a point of concern since they have often suffered damage during re-entry. Strengthening them will likely be one of the next priorities. Other systems on ship also demand attention. These include the payload bay, the fuel tanks and heat shield, and the composite overwrapped pressure vessels. Although these components performed well during Flight 10, they will need to be reinforced and carefully monitored to avoid the kinds of failures that plagued earlier flights. Alongside the vehicle upgrades, SpaceX must also prepare the ground systems, which will play an equally critical role. In order to catch ship, 2 launch towers must be operational. That means Pad 2 at Starbase needs to come online soon. In fact, it could already be operational as early as the first V3 flight later this year. Even before an official catch attempt is made, Pad 2 is currently in the final stages of assembly and has already begun testing. Its design will include significant improvements compared to Pad 1, with upgraded chopsticks, a new orbital launch mount, and a redesigned flame trench. While Pad 1 may continue to serve as the main operational pad, Pad 2 is expected to handle much of the heavy workload in the near future, including supporting future dual-stage catch operations. Beyond the launch towers, SpaceX is also expanding its production and testing capabilities. The Star Factory, which is now ramping toward full capacity, will accelerate the construction of new vehicles, especially the V3 variants. Recent photos have revealed a growing number of nose cones and ring sections inside the factory, showing just how quickly production is scaling up. Nearby, larger assembly bays are also under construction, with the new Gigabay currently in the foundation stage. Once completed, this massive facility will allow SpaceX to assemble multiple boosters and ships simultaneously, dramatically increasing output. Testing infrastructure is another vital piece of the puzzle. The Massey test site will soon return to support static fire testing of both ship and Super Heavy prototypes. A recent milestone at this facility was the completion of cryogenic testing for the booster QD, a key component for fueling operations. Having Massey fully active again will relieve pressure on Pad 1 and ensure that testing can continue in parallel with launch preparations. This ability to test, refine, and launch without delays will be critical to maintaining SpaceX's aggressive schedule. When taken together, these preparations paint a clear picture of how SpaceX is positioning itself for the next stage of Starship development. By building out a robust production system, completing powerful new assembly facilities, expanding its testing infrastructure, and upgrading both ship and Super Heavy, SpaceX is laying the groundwork for reliable catches with the Mechazilla Arms. If everything proceeds as planned, the result will be a constant flow of V3 prototypes, tested thoroughly and flown rapidly. That pace will provide SpaceX with the data and confidence it needs to attempt one of the boldest engineering feats in history, catching the largest rocket ever built, not once, but twice, to achieve true full reusability. There is certainly a lot to look forward to in the new version of Starship, but before SpaceX can get there, the company must first overcome the immediate challenge of Flight 11. The next Starship launch is expected in September or October, and a September flight would mark the first time SpaceX has launched Starship in back-to-back months, setting a new record and accelerating future missions. Hardware for Flight 11, Ship 38, and Booster 17 has already passed cryogenic tests and now awaits pad refurbishment, booster trials, and Ship 38's static fire before final preparations. With Flight 10 free of major failures, no lengthy investigation is required, allowing approvals and reviews to proceed quickly. While Flight 11 will not attempt a catch, it'll push Starship closer to its limits, improving reliability and gathering critical data ahead of the V3 series. Musk's timeline points to late this year and early next as the window for the first true catch attempt, when both stages return to the launch site for full reusability. The stage is nearly set. The question is, are you ready for it? Refilling is the key to Starship's leap in space exploration. After much anticipation, Musk has revealed the timeline for this technology, along with a bold statement that even surprised NASA, which has recently shown skepticism. So when will SpaceX build this system, and why is Musk so confident? Indeed, for many people, the idea of refilling fuel in orbit is one of the most difficult challenges facing SpaceX and its Starship program. It's a task that has never been done before, and the scale becomes even more daunting when it involves a vehicle as massive as Starship. The difficulty of this undertaking has been highlighted by critics, and one of the most notable voices came recently from former NASA Administrator Jim Bridenstine. During a Senate hearing, he raised serious doubts about Starship's capabilities, including whether orbital refilling could ever work. His concerns ranged from questions of launch capability to reliability, as well as whether cryogenic fuels could survive long enough in space to be practical for such a system. Naturally, those comments stirred up plenty of debate, and people waited to hear how Musk would respond. As expected, he turned to X, where he issued a short but powerful statement that gave clarity to SpaceX's timeline and showed his confidence in the plan. Musk said plainly, SpaceX will do orbital refilling several times next year with Starship V3. That is not speculation or a vague estimate anymore. It's a firm commitment. According to Musk, 2026 will be the year SpaceX begins actual orbital refilling operations. His confidence is built not only on plans for the future, but also on the successes of the recent Starship Flight 10. That mission resolved many of the problems that had hindered the previous V2 flights. It also accomplished key objectives directly tied to refilling, such as deploying a payload and successfully relighting engines in space. Building on those results, SpaceX now aims to move into the next phase with Starship V3. Musk has revealed that V3 is already in production and should debut by the end of this year, with a strong operational tempo planned for 2026. This version of Starship includes numerous upgrades, from hot staging and grid fins to an improved heat shield and Raptor 3 engines. But perhaps most importantly, V3 will also feature increased size and fuel capacity, which means it will be far more efficient when conducting refilling operations. Even more striking is Musk's claim that SpaceX will not just attempt refilling once, but will attempt it several times. The schedule appears to make sense. The debut V3 flight later this year will likely serve as a test platform, with subsequent flights, possibly Flight 13 through 15, focusing on catching operations for both stages. These missions may take place early next year. If those flights prove successful, then orbital refilling could begin as early as mid-2026, perhaps around Flight 16. This timeline gives SpaceX several flights to build confidence in the new systems and master all aspects of launch, recovery, and reusability before attempting refilling. That makes sense because the refilling system will play a critical role in ambitious missions, such as the first uncrewed journeys to the Moon or Mars. Now comes the core of the debate. Is orbital refilling actually feasible? Critics say it may not be, but Musk's response shows why he believes otherwise. SpaceX has two main approaches in mind. The first is a direct ship-to-ship transfer. In this method, a fleet of dedicated tanker starships would launch and rendezvous with a primary starship in orbit, transferring cryogenic fuel directly. This requires high reliability in docking and fuel transfer operations, but would make the process relatively fast once the system is proven. The second approach is to establish a depot in orbit, which would allow fuel to be stored and accessed when needed. While this reduces scheduling pressure, it introduces the challenge of long-term cryogenic fuel storage in space. Both ideas sound extremely challenging, but Musk argues they are entirely achievable. In his tweet, he said, "Because we are simply docking with ourselves, this is a much easier problem than docking with the space station, which SpaceX already does several times a year." That statement highlights the biggest advantage of SpaceX's approach. Unlike docking two different spacecraft that were designed by different organizations, docking two starships involves vehicles with identical systems, hardware, and software. This creates a consistency that makes the process far less complex. SpaceX already has extensive experience with docking. The Dragon spacecraft, which regularly ferries crew and cargo to the ISS, has an unbroken track record of success. In just a few years, SpaceX has completed around 50 such missions. Each one required precise navigation, alignment, and docking with a completely separate system. Yet every mission has shown smooth and reliable performance. If Dragon can safely and repeatedly dock with the ISS, then docking two starships which are designed to work together should indeed be a much easier task. Musk's comparison underscores his confidence. For him, refilling in orbit is not an unsolvable engineering problem. It's simply the next step in scaling up capabilities that SpaceX already demonstrates regularly. The schedule is clear and the foundation of expertise is in place. So, what do you think? Do you believe Musk's confidence is justified? Will SpaceX truly be able to achieve orbital refilling several times in 2026 with Starship V3? Share your thoughts in the comments by saying yes or no, and don't forget to like the video and subscribe to follow SpaceX's incredible journey toward making history. Musk's bold statements about orbital refilling have not only shaped the conversation around Starship, but have also had a profound impact on the broader space race. As mentioned earlier, many people, including officials within NASA, remain skeptical about both Starship and its refilling system. Some within the agency have even suggested moving the Artemis program back toward a traditional model centered entirely on the space launch system, while minimizing or eliminating commercial involvement. Yet the reality is clear. The SLS is facing major challenges in cost, progress, and overall reliability. Even now, serious questions remain about whether NASA will be able to prepare two rockets, a spacecraft, and a lunar lander in time for Artemis 3 following Artemis 2. The immense complexity and expense of that model make it difficult to sustain long term. By contrast, Starship, although still in its development phase, is showing rapid progress and tremendous potential. It brings unique advantages with its fully reusable design, immense thrust, and fast production tempo. While the inclusion of orbital refueling adds another step to the process, Musk has consistently emphasized that this challenge will soon be solved. Once it is, Starship's immense lift capacity and versatility will give NASA a decisive edge in building a sustainable presence on the Moon, whether through surface bases or orbital infrastructure. That is why Musk's statements have forced skeptics to reconsider. His confidence in refilling is not only influencing public opinion, but also reshaping internal discussions within NASA. Indeed, there are leaders inside the agency who already see Starship's potential. Acting Administrator Sean Duffy, for example, has expressed optimism in Starship's readiness after speaking with SpaceX executives like Gwynne Shotwell and observing the success of Flight 10. He recognizes that the vehicle vehicle is steadily proving itself and could very well play a central role in Artemis 3. This debate does not stop at the moon. NASA is also struggling with the Mars sample return program, which has been plagued by rising costs, scheduling setbacks, and overwhelming complexity. SpaceX's progress with Starship offers an alternative path forward, one that could enable faster and more direct missions to Mars. The stakes are even higher when viewed in the context of international competition. China has been making rapid strides in space with recent successes in lunar exploration, new rocket systems, and ambitious lander missions. Jim Bridenstine himself has warned that China could surpass the US in the race for the moon. That concern is far from exaggerated. China's record shows consistent momentum, while America risks delays if it does not fully harness its commercial partners. This is where SpaceX's refueling system could become the true turning point. If proven successful, it will guarantee NASA's schedules, strengthen the Artemis program, and accelerate America's push toward Mars. With reliable refueling, Starship will not only enable repeated missions to the moon, but also the establishment of long-term infrastructure. The US could move ahead decisively, leaving its rival in the dust. But in the end, trust and cooperation will be essential. NASA, its partners, and SpaceX must work together with unity and vision if the United States is to win these critical races. With refilling as the key, the door is now open to a future where humanity returns to the moon, travels to Mars, and begins building permanent bases in space. To make these ambitious plans and expectations a reality, SpaceX must begin preparing immediately. The number of prototypes required is enormous, which means that production systems must be upgraded and expanded without delay. At the center of this effort are the Star Factory and the Gigabay, both of which need to be completed and operating at full capacity within this year and the next. These facilities are essential not only to maintain production speed, but also to ensure that Starship is fully prepared for the demanding refilling missions ahead. In addition to scaling up production, SpaceX faces the urgent task of rolling out special mission-specific versions of Starship. One of the most important examples is the HLS variant, designed for the Artemis program's lunar missions. Developing and testing these specialized spacecraft alongside the standard Starship variants will be critical for meeting both NASA's requirements and SpaceX's own long-term objectives. Parallel to production, the testing infrastructure must also be significantly upgraded to handle the demands of version 3. The incident with Ship 36 has already become a milestone that highlighted the need for better test facilities and more refined procedures. Going forward, every test must build confidence in Starship's systems while preparing for the complex challenges of orbital refueling. Finally, the launch infrastructure will need to be expanded and optimized for continuous operations. Refilling missions will require multiple launches in quick succession, which means SpaceX must be able to rotate vehicles and refurbish launch pads at record speed. Work is already underway to upgrade Pad 2 at Starbase and LC-39A at Kennedy Space Center. In addition, SpaceX has acquired the SLC-37 platform, which could eventually host at least 2 more launch pads. Together, these systems will create the backbone of a high-cadence launch campaign necessary for refilling operations. In terms of flight progress, the upcoming window of opportunities from Flight 11 to Flight 15 will be critical. During these missions, SpaceX must master key milestones such as completing the full flight sequence, deploying payloads accurately, relighting engines in orbit, and demonstrating controlled landings using different methods. Among these, catching Starship with the Mechazilla Arms will be one of the most important achievements. Reaching these goals as early as possible will free up valuable time and give SpaceX the confidence to move swiftly into orbital refilling. We are standing on the edge of another groundbreaking achievement in space exploration. There will always be skepticism, and many continue to doubt whether such an ambitious system can succeed. Yet, SpaceX has a history of turning the impossible into reality, and the confidence and timelines shared by Musk and his team suggest that history is about to repeat itself. The year 2026 may very well be the turning point, when the refilling system begins to operate and unlocks the full potential of Starship. Everything is moving quickly, and those who follow closely will witness a new era unfolding before their very eyes. SpaceX has completed a static fire test with its next reused booster, launching an ambitious schedule and opening a new chapter for pad operations. Meanwhile, in Florida, the Starship program pushes ahead despite major challenges, while Falcon 9 and Starlink continue reaching new milestones that showcase steady progress on multiple fronts. SpaceX is truly ramping up momentum following the remarkable success of Flight 10, and all signs now point toward an accelerated push for Flight 11. As noted in the previous episode, B-15 was moved to the launch pad just 11 days after Flight 10, a clear demonstration of how quickly SpaceX is working and how prepared the team is across multiple aspects of the program. This rapid turnaround is already setting new records and raising expectations. After B-15's arrival at the launch pad, it was immediately lifted onto the orbital launch mount on the morning of September 6th, where it stood ready for testing during the announced window between 5 in the morning to 12 noon on September 7th. Preparations began promptly on the 6th, with the booster transport stand leaving the launch pad and heading back to the Hoppy parking lot, which is a routine part of setup. Later that evening, activity picked up once more. A short test window revealed strong venting that indicated the detonation suppression system was being checked. Soon after, the chopsticks were raised, and the ship quick disconnect arm was retracted, further signaling that the booster was entering its final preparations. By the early morning of the 7th, the unmistakable signs of a fueling operation began. Frost bands appeared on the tank walls, showing that liquid oxygen was being fully loaded into the liquid oxygen tank, while the methane tank was filled to about one-third capacity. These steps were clear indications that the team was closing in on the static fire test. When the moment arrived, Starbase came alive. More than 350,000 gallons of water rushed across the flame trench to suppress sound and heat, and then all 33 Raptor engines roared to life. The ground shook, nearby cameras caught vibrations and small debris, and SpaceX confirmed success by sharing stunning footage accompanied by the announcement, static fire complete for the Super Heavy booster preparing for Starship's 11th flight test. According to the footage and data, all 33 engines fired simultaneously, generating over 7,000 tons of thrust. The burn lasted for 8 full seconds, long enough to validate both the booster and the pad systems. Importantly, the test concluded without any reported issues, which was further confirmed by the smooth sequence of post-test operations. The chopsticks lowered back into place, the ship QD arm reattached, and the booster's support equipment, including the transport stand and Raptor work platform, were returned to the pad for inspection. Soon after, Cameron County announced a closure schedule for the booster's transport back to the production site, set between 10 in the morning to 2 in the afternoon on the 8th. This marks another major step forward for Flight 11. Once back inside the Mega Bay, B-15 will undergo inspections before hot staging hardware and the flight termination system are installed. These inspections are particularly important because B-15 is a reused booster, having previously flown on Flight 8. Engineers will pay close attention to problem areas from its earlier flight, such as the middle ring engines that experienced failures during boost back and landing burns. Flight 11 will thus become the second Starship mission to fly with a reused booster, another crucial milestone in proving the viability of rapid turnaround and reusability within the Starship program. If successful, this will build confidence for the even greater challenge ahead, which is recovering and reusing the Starship upper stage itself. Speaking of the ship, S-38 is also approaching readiness. At this point, its engines are expected to be installed, but before rollout, SpaceX must finish inspections on the launch pad and reinstall the ship test system. Following recent patterns, S-38 will likely go through at least 2 major static fire tests, one with a single engine and another with the full cluster, to validate performance before flight. After the S-37 campaign, much of the testing hardware was moved to the Sanchez site, but preparations suggest that everything is nearly ready to return. If the current pace continues, S-38 could be moved and tested within a week, with another week or more reserved for final payload integration and installation of the FTS system. This timeline keeps the possibility of a September launch alive, particularly after the smooth B-15 static fire. So will Flight 11 take off this month? That remains the big question. The pace suggests it's possible, and personally, my prediction is the 29th of this month. What do you think? Respond with yes or no in the comments along with your prediction for the launch date. The vision that emerges after the successful B-15 static fire test goes beyond a single booster or even a single flight. It marks the beginning of a new era for SpaceX's launch pads, an evolution that will define the next stage of Starship's development. B-15 is very likely the last V-1 booster to take to the skies. Starting with the next flight, both Ship and Super Heavy are expected to transition to the new V-3 design. This This change also means that Pad 1, with its current OLM, chopsticks, and water-cooled steel plates, will no longer be suitable for the demands of future missions. These systems were remarkable for their time, but they were always intended as stepping stones rather than permanent solutions. As a result, Flight 11 may well be the final booster test conducted at Pad 1 before SpaceX shifts booster testing and launch operations to the newly built Pad 2. That site is now in the final stages of installation and is expected to be tested for operations within the last months of this year. Looking back, it's clear that Pad 1 deserves recognition for its role in shaping the early days of Starship. From full-stack integration tests to 10 historic flights with one more still to come, Pad 1 has endured countless challenges and proven its strength. While it may not be capable of sustaining long-term operations in its current form, it'll forever stand as a symbol of Starship's earliest breakthroughs and the foundation of its journey. The end of Pad 1's current role does not mean the end of Pad 1 itself. Once Flight 11 is complete, the pad will undergo extensive upgrades. The 6-legged orbital launch mount and the steel plate will be replaced with a new OLM and a flame trench system similar to what Pad 2 is receiving. Other systems, including the chopsticks, SQD, and BQD, will also be modernized. If SpaceX continues its current pace, Pad 1 could return to service by late next year, just in time to support a wave of critical missions. This is part of a much larger expansion effort. Beyond Pad 1, SpaceX is preparing upgrades at Kennedy Space Center's LC-39A, beginning work on a new pad at Cape Canaveral's SLC-37, and even planning additional pads at Starbase as the site grows. Each new development strengthens SpaceX's capacity to support frequent launches, paving the way for the scale of operations needed for deep space exploration. Pad 1 may soon step aside, but it'll also lead the way into this new chapter. So let us honor its contribution by looking forward to its future. If you support the upgrades, respond in the comments with "Evolve every day," and do not forget to like the video and subscribe to our channel to continue following SpaceX's extraordinary development journey. SpaceX's plan to expand Starship operations to Florida represents one of the most ambitious steps in the program's journey, but it's far from a straightforward process. The path is shaped not only by engineering challenges, but also by regulatory, environmental, and community considerations. The FAA plays a central role in this effort. As part of the approval process, the FAA has released multiple draft environmental impact statements, or EIS, which assess the potential consequences of Starship operations in Florida. These drafts are followed by periods of public comment and formal hearings before the final EIS can be issued and official approval granted. Recently, the FAA concluded a series of public hearings focused on Starship's presence at Kennedy Space Center, including proposed launch and landing activities as well as ocean-based recoveries using drone ships stationed in the Atlantic, Pacific, and Indian Oceans. However, the hearings highlighted several concerns that cannot be ignored. Due to Starship's massive scale compared to Falcon 9, safety zones for both air and sea traffic will need to expand significantly. This translates to larger exclusion zones around the launch site and more frequent closures. According to the analysis, Playa Linda Beach, a popular recreational site, could face more than 60 closures each year. Additionally, commercial air traffic across Florida may experience delays ranging from 40 minutes to 2 hours during launch windows. Maritime operations, particularly at Port Canaveral, will also be affected due to temporary navigation restrictions. Local voices have added to the debate. Aviation officials, including Tampa International Airport's COO John Tiliakos, emphasized the risks to Florida's busy air travel system. Tiliakos warned that Starship's schedule could result in significant impact to commercial aviation and the traveling public, urging the FAA to find mitigation strategies. Others raised health and quality of life issues. Robin Memphis, a neuroscience and psychology graduate student, pointed out that launch noise and sonic booms could trigger chronic sleep disruption. She linked this to risks of depression, anxiety, cardiovascular disease, and even suicide, noting that Florida's large population of veterans and trauma survivors make the issue particularly concerning. Even less expected groups voiced opposition, such as the American Association for Nude Recreation, which argued that frequent closures of certain areas would interfere with their members' rights, and the tourism tied to legal potential nudist locations. Yet support for Starship in Florida remains strong. Many see it as a vital leap for humanity's future in space. Photographers and enthusiasts like Max West expressed their excitement, acknowledging that while there may be little sacrifices along the way, such as disruptions to wildlife or recreation, the greater progress outweighs the drawbacks. Large institutions, including NASA and government bodies, are firmly behind the project, given Starship's role in lunar missions, Mars ambitions, and expanding America's spaceflight capabilities. Ultimately, Florida stands at a crossroads. The state could soon host the most powerful rocket system in history, but the decision comes with trade-offs that affect daily life, tourism, and the environment. Whether the community embraces or resists these changes will help shape Starship's future beyond Texas. What about you? Do you support Starship coming to Florida? Share your thoughts in the comment section down below. As that question lingers, one thing remains clear. SpaceX is already reshaping modern rocketry. On September 5th, a Falcon 9 launched from Florida's LC-39A, carrying another batch of Starlink satellites. While routine for SpaceX, the mission's recovery marked history. Booster B-1069 lasted on just read the instructions, achieving its 27th landing and bringing SpaceX to its 500th Orbital-class launch and landing. Musk celebrated the feat, writing, "Congrats, SpaceX team, on 500 orbital rocket launches and landings." This milestone underscores the company's unmatched mastery of reusability. The very next day, another Falcon 9 lifted off from California with more Starlink satellites, pushing 2025's total satellites launched past 2,000 and raising the overall constellation above 9,600. Of these, over 8,300 remain active, forming the largest satellite network ever built. Competitors like Amazon's Project Kuiper are just beginning, but the gap is vast. SpaceX is already on pace to surpass 12,000 satellites as soon as next year. Each launch is more than a mission. It's proof of reliability, cost efficiency, and relentless momentum. With records falling at an unprecedented pace, the only question left is how quickly SpaceX will reach the next milestone. For years, the aerospace world could only wonder what lay inside SpaceX's Star Factory, glimpsing it through windows or distant shots while its true scale remained hidden. That mystery ended when Elon Musk released a video revealing the vast Starship fleet within, an extraordinary sight that redefines ambition. The interior of SpaceX's Star Factory has long been one of the most guarded mysteries of the Starship program. For years, both the aerospace industry and the public have speculated about what goes on inside, relying on only fleeting glimpses through windows or rare exterior shots. The most revealing look until recently came during Elon Musk's interview with Everyday Astronaut, when the facility was still in its infancy. At that time, viewers saw only a lone nose cone and a few non-operational production lines. The full scale of operations remained hidden, leaving curiosity to build. That curiosity was finally rewarded when Musk released a short video just days ago. Though only 41 seconds long and showing just one corner of the vast facility, the clip was enough to astonish the world. Soon after, SpaceX added to the excitement by sharing even closer footage of hardware inside the Star Factory during the live stream of Starship's second launch attempt on the 25th of August. For the second time, the curtain was lifted, offering a real sense of the industrial power behind Starship's production. The footage revealed details that spoke volumes about scale and capability. Rows of nose cones appeared at both the start and end of the video, the clearest evidence yet of just how many vehicles SpaceX is producing in parallel. By observation, at least 7 nose cones were visible, 4 nearly complete, 1 being stacked, and another that may or may not have been a nose cone, but bore its distinct shape. The nearest one appeared to be under assembly against a short wall. This single angle confirmed hardware readiness for Starship's S-46 through 50, and likely beyond. Another perspective in the video highlighted stainless steel sections along production line, no fewer than 15 segments already welded and awaiting further processing. That number alone suggests SpaceX has the pieces to build multiple Super Heavy boosters and Starship upper stages without delay. Nearby, smaller spherical tanks, truncated cones, and large domes could be seen. most likely header tanks and fuel tank domes essential to Starship's structure. The sheer variety of components in view underscored a crucial point. The Star Factory is not producing isolated parts, but entire suites of hardware ready to flow directly into vehicle assembly. Much of the hardware on display appears tied to the Starship V3 design. With Ship 38 set to conclude the V2 series, production is already pivoting toward the next generation. S-39, fitted with forward flaps and heat shield, and recently stacked with its payload section, marks the true beginning of V3. This transition signals not only refinement but acceleration. Where once there were doubts about SpaceX's ability to keep pace with hardware demand, the challenge now is whether the assembly bay itself can keep up with the flood of parts streaming in from the Star Factory. The facility's impact lies not just in scale but in its advanced technology. Inside the Star Factory is bright, orderly, and strikingly modern, reflecting precision as much as size. It houses world-class equipment for bending, stamping, polishing, and welding stainless steel. Among the most notable techniques is tip-TIG welding, a laser-assisted process that produces cleaner, stronger seams. The difference is visible in the nose cones. Early prototypes bore rough, obvious welds, but today's versions show seams so smooth they are nearly invisible. This is not simply aesthetic refinement, it ensures durability and reliability for spacecraft designed to endure extreme conditions. The Star Factory also embodies a distinct production philosophy. Inspired by Tesla's automotive assembly methods, SpaceX has implemented a linear production line designed around specialization. Each station focuses on one task or component, enabling machines and workers to operate with efficiency and precision. This approach eliminates bottlenecks, keeping the entire process in constant motion. The result is speed, a synchronized rhythm of production that accelerates output to levels unmatched in aerospace. That accelerates output to levels unmatched in aerospace. What emerges from these brief glimpses is a new understanding of SpaceX's industrial might. The Star Factory is no longer a mystery. It is a clear symbol of the future of Starship. Within those walls lies the engine of routine production for the world's most powerful rocket, a factory designed not just for prototypes, but for fleets. And if 41 seconds of video can reveal this much, the full scope of the facility, once fully unveiled, will likely redefine what is possible in space manufacturing. The quality factor is also significantly improved with the Star Factory system. When each station only focuses on one specific task, any issues that arise can be quickly identified and addressed. If a defect occurs, the monitoring system can immediately pinpoint the exact station where it originated. This streamlined process saves a great deal of time and effort, ensuring higher reliability in production. Another advantage is the structure of the Star Factory itself. Unlike the earlier production tents, which required parts and workers to constantly move between separate facilities, the new factory consolidates operations under one roof. Musk often refers to this as a true building rather than a temporary tent system. By bringing every step of production into one enclosed space, operations flow seamlessly, without interruptions caused by movement or environmental conditions. Additionally, the closed environment shields the production line from weather factors such as wind, rain, or extreme temperatures, all of which previously disrupted work at Starbase. It is worth noting that the Star Factory is not yet operating at its full capacity. SpaceX is still in the process of gradually ramping up. Full production capability may come into effect later this year or early next year. When that happens, the scale of Starship development will accelerate dramatically. Based on current progress, it's reasonable to expect that SpaceX could build and even test at least 2 to 3 Starship V3 prototypes before the year ends. Among these, one pair of V3 vehicles, S-39 and B-18, are expected to fly together on Flight 12. Next year, this pace is set to increase even further. This preparation will be essential for what SpaceX envisions as an explosive phase in 2026. Internal plans have suggested the goal of up to 25 launches in a single year. Proposals for 44 annual launches from Launch Complex 39A and 76 from Space Launch Complex 37 have been discussed. During the optimal Mars transfer windows, SpaceX even anticipates up to 10 flights per day. In fact, Musk recently hinted that the company could reach a turnaround rate of more than 24 flights per day. That would mean daily launches of Starship and potentially hourly launches for Super Heavy. Such ambitious goals require not only speed but also a massive number of prototypes. Starship continues to evolve. While V3 is the most refined yet, Musk has already outlined V4, longer, more powerful, with added engines and aiming for flight in 2027. Supporting this vision requires the Star Factory, with similar facilities likely to expand beyond Starbase, possibly to Florida. Over time, more factories will be needed to match Musk's ambitions, and seeing the systems now now revealed inside, one can only say, wow, the future here is unlike anything seen before. But remember that the development of Starship does not come only from the Star Factory. It also relies on a wide series of interconnected systems that must evolve together in order to sustain progress. At the production site, for instance, there is already a need for new structures. In the near future, the existing bays will no longer be sufficient to handle the stacking of the growing number of starships. This challenge will only become greater as the rocket itself increases in size. Musk has already unveiled the next iteration, Starship V4, which will feature more engines and larger dimensions than the current versions. In order to accommodate this scale, the bay structures themselves must continue to expand. Right now, the production site at Starbase is in the middle of a major transition. Earlier this year, the original high bay was demolished to make way for a much larger structure, both taller and wider, known as Gigabay. According to information revealed so far, Gigabay will have the ability to simultaneously house many Super Heavy boosters and Starship prototypes. Inside, there will be between 10 to 20 work platforms equipped with advanced technology to support every stage of assembly. This includes stacking, inspections, installations, and even refurbishments. Construction on Gigabay has already begun at Starbase, and SpaceX also intends to build another Gigabay in Florida. With facilities of this scale, the pace of work established by the Star Factory can be maintained and accelerated, ensuring that SpaceX has the number of prototypes it needs for the missions ahead. When production becomes this robust, the systems that follow naturally need to be just as strong. The next step is the test system. For many years, testing has received less public attention compared to the production facilities or the launchpads. However, moving forward, the importance of the test system cannot be overstated. In fact, the focus on testing increased dramatically this year after a major setback occurred during the S-36 test failure. That incident caused serious damage and forced SpaceX to pause operations while the site was repaired. It was during this period that SpaceX began reinforcing the testing infrastructure with upgrades such as the installation of the V3 booster QD. Still, in order to support continuous operations, the testing system will need to grow beyond its current limits at the Massey area. By expanding into additional test sites, SpaceX can maintain a consistent testing cadence and avoid complete interruptions if one site suffers damage. This redundancy will be critical in supporting rapid iteration and keeping development timelines intact. Similar to test systems, the launch system also requires significant upgrades and expansions. At present, SpaceX has 2 orbital launch pads at Starbase. Pad 1 is operational, and Pad 2 is nearly ready to come online. Pad 2 has been designed as a model for the future, incorporating lessons from previous flights. Once Pad 2 begins operations, Pad 1 will also undergo modifications to bring it up to the same standard. This model has already started to influence Pad LC-39A in Florida, where similar upgrades are underway. Beyond upgrades, the total number of launch pads must also increase. While LC-39A is limited in how much it can expand, both Starbase and SLC-37 in Florida have greater potential. Plans for SLC-37 currently envision at least a 2-pad system, while Starbase is expected to grow beyond its current pair of pads once land acquisition allows. More pads will mean more frequent launches, which is essential if SpaceX is to achieve its ambitious targets. Additionally, extra pads will support Starship's landing and reuse, a capability that sets it apart from other rockets and remains central to Musk's long-term vision. Taken together, these developments allow us to imagine an extraordinary future for Starship. While the future always carries uncertainty, the massive fleet of vehicles already visible inside the Star Factory is proof of how far the program has come. The Star Factory is only the beginning of a much larger process. SpaceX will continue to expand every system, from production to testing to launch, in order to optimize the operations of its Starship fleet. Progress has been steady, progress is ongoing, and progress will continue at a relentless pace. For those following this journey, the message is simple. Stay focused, because the most important moments are still to come. Spin Launch once made headlines with its bold plan to fling payloads into orbit using a giant kinetic launcher. Now the company has shifted away from that vision and is pursuing a new direction. What is Spin Launch working on today? And why the change? It can be said that when it was first proposed a few years ago, the Spin Launch Orbital Accelerator System immediately attracted attention across the space industry. However, achieving that vision has proven to be extraordinarily difficult. To this day, the company has not been able to bring the orbital accelerator anywhere near its intended operational capacity. In light of these challenges, Spin Launch has recently shifted attention toward another major project, one that could redefine the company's path forward. That project is called Meridian Space, a planned satellite constellation system. Spin Launch appears to be betting heavily on this new initiative. According to recent updates, the company has secured $30 million in new investment to develop Meridian Space, with backing from existing partners such as ATW Partners and previously announced commitments from Kongsberg Defense and Aerospace. Notably, Spin Launch raised $12 million from Kongsberg earlier this year, and in 2023, it successfully closed an $11.5 million round of funding. The company has set an ambitious timeline for Meridian Space, targeting its first customer link in the second half of 2026, while accelerating efforts to bring the system to market. Expanding into satellite services is not unusual, as many space companies are now pursuing integrated business models that combine launch capability with satellite networks. However, Spin Launch's pivot raises deeper questions about its identity. Instead of launching the Meridian satellites with their own kinetic accelerator, Spin Launch will likely depend on conventional rockets to meet deadlines. This marks a significant departure from the company's original mission to disrupt the rocket industry altogether. While Spin Launch insists that development of the orbital accelerator will continue and eventually support satellite launches, there's no clear timeline for when that system will be ready. In practice, this new focus on Meridian Space highlights the technical and logistical problems that have plagued the accelerator since its inception. Founded in 2014 in California, Spin Launch quickly became known for its daring attempt to build a kinetic launch system. The company constructed its first prototype in New Mexico and conducted a series of 10 test launches in 2021 and 2022. These tests proved the system could work in principle, but progress stalled afterward. The most successful attempt reached an altitude of just 10 kilometers at a velocity of 1,600 kilometers per hour. That is a remarkable engineering feat, but it falls drastically short of the target of 300 kilometers altitude and the 25,000 kilometers per hour velocity required to place a payload into orbit. The challenges are immense. To achieve orbit, payloads must survive passage through Earth's dense atmosphere, which demands enormous kinetic force. Generating that force is already difficult, but even if achieved, the payload faces severe risks of structural damage. Before reaching the atmosphere, the payload also endures violent rotational forces inside the vacuum chamber of the accelerator itself. The sudden transitions, intense vibrations, and mechanical stress pose serious risks of failure long before orbital velocity is even approached. For these reasons, some analysts have suggested that the Spin Launch system might be more suitable for environments beyond Earth. On celestial bodies like the Moon or Mars, where the atmosphere is thin or non-existent, many of the system's biggest obstacles would disappear. Such a system could provide a simple and fuel-efficient means of launching payloads in the early stages of human settlement, which full-scale rocket infrastructure is not yet available. Without needing fuel to launch, precious propellant could instead be reserved for other mission-critical maneuvers. In theory, Spin Launch could become a valuable asset for programs like Artemis on the Moon or future Mars missions. Yet, so far, neither NASA nor Spin Launch has formally embraced this concept. Another fundamental issue lies in the compatibility of the orbital accelerator with modern propulsion trends. The system's extreme vibrations and accelerations make it unsuitable for liquid-fueled payloads, which are now the standard across much of the industry. Liquid fuel is sensitive to sloshing, which can destabilize or damage vehicles under heavy stress. This means Spin Launch's system is only truly compatible with solid-fueled payloads. Since solid fuel is increasingly less common in new spacecraft design, the company risks losing a large portion of the market even if the accelerator were perfected. By contrast, traditional rockets continue to evolve and maintain wide compatibility with both solid and liquid fuel systems. Taken together, Spin Launch's situation presents a fascinating contradiction. On one hand, its orbital accelerator remains one of the most daring and innovative ideas in the aerospace sector, a concept that could still reshape space access if the technical challenges can be overcome. On the other hand, its lack of progress, compatibility issues, and the need to rely on rockets for Meridian space demonstrate that the company may be quietly stepping away from its disruptive roots. The coming years will be decisive. If Spin Launch can successfully bring Meridian Space to market by 2026, it may carve out a new identity as a satellite operator while continuing slow development of the accelerator in the background. If not, the company risks being remembered as a bold idea that could not survive the brutal realities of spaceflight. Either way, Spin Launch has ensured that the industry is watching closely. Because even if its original dream remains out of reach for now, the story is far from over. Another major obstacle for Spin Launch lies in the construction of the accelerator itself. To achieve orbital velocity, the system must be capable of generating enormous amounts of force, which requires an immense structure. Estimates suggest that an operational orbital accelerator would need to measure around 100 meters in diameter, yet up to this point, Spin Launch has only developed two suborbital versions of the technology. The first is a 33-meter test accelerator located in New Mexico, while the second, much smaller, is a 12-meter version in California. The company has explored various sites in its search for a location to build a full-scale orbital accelerator, including Hawaii, Alaska, and even international options. However, it has encountered significant obstacles ranging from regulatory pushback to conflicts of interest with indigenous communities. Despite these setbacks, Spin Launch has made some progress. The company has reached an agreement with the Aleut Corporation in Alaska to explore the possibility of constructing an orbital accelerator on Attic Island. Still, as of now, there is no clear timeline for when construction might begin or when such a facility could realistically be completed. This uncertainty highlights a broader issue. For a system as new and unproven as Spin Launch's accelerator, the road to competing with traditional rockets is steep and filled with challenges. Despite the inherent complexity and expense of rocket launches, rockets remain the most effective and reliable way to deliver payloads into orbit. Moreover, the rocket industry is not stagnant. It is continuing to grow at an unprecedented pace, with new companies and established organizations alike advancing their capabilities year after year. In such an environment, the difficulty for a fledgling system like Spin Launch is not simply technical, but competitive. A single example makes this point clear. Take SpaceX, the undisputed leader in today's launch market. For roughly 15 years, its Falcon family of rockets has set record after record, transforming the economics of space access. Falcon 9 has become the most frequently launched rocket in the world, and its pace continues to accelerate. In recent years, the vehicle has completed more than 100 launches annually, with the shortest gap between flights measured in mere hours. The rocket's capability is equally impressive, with Falcon 9 capable of lifting up to 22 tons to low Earth orbit. Its partial reusability has also redefined what is possible in terms of launch costs, flexibility, and turnaround time. For Spin Launch, catching up seems increasingly unlikely. In short, Spin Launch faces two major disadvantages. The first is that its accelerator system remains incomplete and far from demonstrating orbital capability. The second is that the traditional rocket industry, led by giants like SpaceX, is advancing too quickly for an alternative system to gain meaningful traction. For Spin Launch, the dream of competing with or replacing rockets is no longer realistic. This shift in direction is evident in the company's latest pivot. Instead of relying on the accelerator, Spin Launch is investing heavily in a satellite constellation project known as Meridian Space. Produced in collaboration with Kongsberg Nano Avionics, these satellites weigh about 70 kilos each. Their design removes bulky components such as 2D scanning antennas in favor of streamlined and energy-efficient structures that resemble panels stacked neatly within a rocket fairing. This design allows cost reductions, shorter manufacturing cycles, and the potential for mass deployment. The company estimates that up to 250 satellites could be launched at once, a number that it claims could even surpass the payload capacity of SpaceX's transporter rideshare missions. Meridian space satellites will also feature modern technologies, including ultra-efficient reflector ray antenna systems. With a constellation of approximately 1,190 satellites, Spin Launch projects that it could deliver tens of terabits per second of connectivity. David Wren, Chief Innovation Officer at Spin Launch, emphasized the importance of this development, stating that testing the reflector array antenna proves the system can achieve multi-band capability without the cost and complexity of traditional designs. He described this as a critical step toward realizing the Meridian space constellation and achieving both technical and operational goals. Yet, despite these strengths, challenges remain. Spin Launch will still need rockets to launch these satellites into orbit, which means returning to the very industry it once sought to disrupt. Moreover, the satellite market is fiercely competitive. SpaceX's Starlink constellation already dominates with thousands of satellites in orbit and a continuous pace of deployment. Other players, such as Amazon's Kuiper project, are also scaling up rapidly. By the time Meridian Space becomes operational, competitors may already hold an overwhelming lead. For Spin Launch, the path forward is increasingly complex. The accelerator, once hailed as revolutionary, remains a work in progress. Its uniqueness as a concept is fading as the company shifts towards satellites, a market that is already overcrowded, crowded, and fiercely contested. Whether Meridian Space can provide Spin Launch with the foothold it needs remains uncertain. But one fact is clear: competing against rockets and established satellite constellations will be an immense challenge. Indeed, competition is never easy for a newcomer, especially one taking an untested path. Spin Launch is a prime example, pursuing a launch method no one else has tried. While the idea offers clear advantages, the challenges are immense, and rivals continue to set a high bar in space access. Now the company faces a crossroads: refine its orbital accelerator or pivot to a new direction, risking the unique identity that made it stand out. The decisions made today will shape Spin Launch's future. Can they overcome these obstacles and secure a place in the space industry? Share your thoughts in the comments section down below. Otherwise, folks, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.